Hi, my name is Nelson Gomez, and we're going to try to do the second problem from the example take. Now, again, remember, try to do it first before looking at the answer here. Let me read the problem. On average, the weight of electric stoves is 331.68 pounds, with a standard deviation of 38.71 pounds. Assume the distribution for the weight of electric stoves is approximately normal. Based on these facts, what is the cutoff weight for the highest 1.5% of electric stoves? Okay, first here, one of the easy way to think about this problem is noticing that the distribution is approximately normal. That is actually saying something about the distribution right now. Okay. That is approximately normal. So immediately when you see a problem like that, you probably should try to do something like this and say, okay, this apparently is approximately normal. And then you get the average weight that will be for us, consider mu, the 331.68 pounds, with a standard deviation, in this case, a sigma of around 38.71 pounds. Now, what they're asking here from us is to determine what is the cutoff weight for the highest 1.5% of electric stoves. So here's the idea. There is a point where you will find the highest 1%, for example, of stoves. That is pretty high, right? Pretty high, you find that high 1%. Now, the high 1.5% will be also extremely high. So 1.5% is around there, right? Not this is not to scale, just in case. 1.5% is around there. So what they're asking us is, based on this data, what is the amount of pounds, the weight that should be there? What is the cutoff weight for the highest 1.5% of electric stoves? So that means that 98.5% of the stoves will have a lower weight than this weight. Okay, so only 1.5% of electric stoves are higher than this weight. Now, to do that, you have to remember how the C table works, or how the standard normal distribution works. But first, let me show you this. So let me grab another color here. And if you remember, the C table always gives us the percentile, the percentage of data that is below that point. So the C table always works like this. That's what the C table gives us. Now we want to know, what is the probability that there is a number, the probability that it is a number that have a 0.9850 as its percentile. Why this number? Because if you remember, the sum of whatever is here in blue and red should be 1 or 100%, whatever way you see to look into it. So let's say 100%. So it will be, okay, 100% minus 1.5% that will get us 98.5%. Or the way I will prefer, 1 minus 0.015, and that will be 0.985. But again, if you remember the C table, yeah, it would be great for you to think about it this way, 0.9850. Now, knowing this, let's go to the C table and let's start looking for that 98.5. And if you start looking about it, and 98, okay, aquí está no, era 98.5, so we need to look over here, let's see, 98, oh, 98.50. It's a perfect fit for us. That is not that common. Sometimes it's between two numbers. What I ask you to do is to select the closer one between the two really closest one, okay? And in this case, that will mean that the C value is 2.17. So let's go back. Let's go back and identify what we're saying. We're saying that there is a C value. There is a C value for which this is true, and that is 2.17. When C is less than 2.17, then that will be the percentile, the probability that is below that. Now, that's not the answer. That is part of the solution, because they're asking us what is the cutoff weight. So now you have to remember the formula for the C score. So that's X minus mu, the average for the population, over sigma, the standard deviation of the population. And now if you do if you solve for X, you will have that X equals to mu plus C sigma. Okay, mu plus C sigma. Mu, we have that. Mu is the 331.68. C, we have C, that's 2.17. And sigma, we have it as well, that's 38.71. Okay, we calculate that, and that would be 415.68 pounds. So this will be the answer for this question. Therefore, this is what we're saying. Here, 415.68 is the cutoff for the highest 1.5% of electric stoves. You can also think of it as the cutoff for the lowest 98.5%. It's the same idea here. Remember, here we have the 98.5% because we have 1.5% more than this value. Okay, I hope this was useful for you.